Good afternoon. Today we are starting book 3, our final book for our final trimester coming up of Tri 3. We are going to be working today with function tables. So we are starting with Po46. I can create a function table for a given equation.
I just said it's a free page.
Is it?
Yeah.
Oh, so we've got a lot to do today. Oh, goodness. Gotta get started. So, first thing we have to do is we have to learn all the different vocabulary words. We are going to be using these words as we go through this unit. Culture, not reception. Okay, so let's look at our words that work with the function table. First is the input. The input is what you plug into an equation. Another way to look at it is to say what is being tested. So when we have a variable, it's what you're putting into for that variable. The output is the result of the equation. Or test. It's what you get out of it. So you put in the variable amount and you get out after you do the equation. Okay. So a function table is a way to organize multiple inputs and outputs to get ordered pairs to graph. So we're going to be working with function tables, and then we're going to be working with graphing of it all. So this starts off with some objectives that you go, oh, okay, this objective, once we learn all the vocab words, we're gonna go, okay, this is pretty easy, but then we go deeper into it and we build on what we've learned in the past. We're gonna learn new things to go with it. So the equation we get from a function table is known as the rule of the table. Okay, so we do the same thing every time. So when we look at the pattern pages in our math packets, we have a table and we say, okay, how is it increasing every time? If we're looking at the blues in the packet number 8, how are they increasing? What is the rule for that part of the table, right? I always tell us, look for those perfect squares. Packet number 8, perfect squares comes into play again. Think about what the rule is for those perfect squares, right? That's the rule of that table. So we're going to create a function table with at least 4 inputs and outputs for each equation given. You need to have at least 4 so you can see that pattern. All right, if we only put 2, we can't see what the pattern is. We want to see those patterns. Remember, you can choose the inputs for your table. So what you're putting in, you get to choose what you're putting in for these function tables. So we're going to choose smart ones. And I'm going to show you what that means. I'm going to erase this so I can scroll up. All right. So let's look at these examples. All right, we have our x and our y, and I know I need to have at least 4. So 4 x's, x is the input, what I'm going to put in for that x, and then what I get out is what y equals after I do the math. So when it's just something regular like this, I like to keep it simple. And I like to do 1, 2, 3, 4. So if I'm putting a 1 in for my x, and then I do the math, what do I get out for my y? Clara?
4.
4. Because if I put 1 in for x, 1 plus 3 equals 4. So I get out a 4. What if I put the 2 in for the x? What do I get out for my y, Holland?
5.
What if I put a 3 in for the x? What do I get out for my y, Elliot?
6.
And if I put a 4 in for the x, what do I get out for the y, Finley? 7. Okay. That one was a pretty basic one. Let's look at our next one. We make our x and y, and I'm going to put 4 spots there because we have to have at least 4. What do you think I should put in for the x? What should I put in? Elliot? I like to just, we can just keep going. Do I have to put in 1, 2, 3, 4? You get to choose. Okay, you decide what you want to put in. If I put a 1 in for my x and I do the math, what do I get out for my y? What operation is happening when I have negative 2x? What operation, what math do we have to do, Laurel?
Multiplication.
Multiply, because we know when that number's right next to the variable, it means we're multiplying it. So what is negative 2 times 1? Laurel? Negative 2. What if I put a 2 in for x? What do I get? Finley? What if I put a 3 in for the x? What do I get? Grayson, what would I get if I put a 3 in for the x? Negative 6. What if I put 4 in? What would I get? Ellie? Negative 8. So now, our next one, got a little bit more we're doing with it. So we're still going to put in 4 x's, 4 inputs. I like 1, 2, 3, 4. I can see my patterns easily. Instead of just randomly choosing, I'm going to put a 1 in, I'm going to put a 5 in, then I'll do a 7, and then I'll do the 3. It's not as easy to see the pattern. But it wouldn't be wrong as long as your output matches with that input. I like to be a little more organized so I can see my patterns. 4, 5, 6, 7, I can see I'm following the pattern. Negative 2, negative 4, negative 6, negative 8, I'm following the pattern. Okay. So if you keep it organized for your inputs, the outputs, the outputs will form a pattern, and you can make sure that you're doing your math correctly, because we know how easy it is to make simple mistakes. Let's look at this one. If I put if I put a 1 in for my x, what would my output be? Laurel? Negative 3. Because 5 times 1 is 5, minus 8 puts me on the negative side of that number line. So I get a negative 3. What if I put a 2 in for my x? Clara?
2.
2 times 5 is 10. 10 minus 8 is 2. What if I put a 3 in, Gavin?
7.
3 times 5 is 15. 15 minus 8 is 7. What if I put a 4 in, Finley?
12.
4 times 5 is 20. 20 minus 8 leaves me that 12. And I can see I'm increasing by 5 every time for my outputs. So there's that pattern. I'm doing my math correctly. Let's look at our next one. I'm just sticking with the 1, 2, 3, 4. When you do your work, you can decide if that's what works for you. If I put a 1 in for my input, what am I going to get for my output? We can do that math. If I put the 1 in, so that's saying 1 squared minus 10. What would I get, Henry?
-9.
Negative 9. Because 1 squared is 1. 1 minus 10 is negative 9. What if I put a 2 in? Violet?
-6.
2 squared is 4. 4 minus 10 is negative 6. What if I put a 3 in? Elliot?
-1.
3 squared is 9. 9 minus 10 is negative 1. What if I put a 4 in? Laura?
6.
4 squared is 16. 16 minus 10 is 6. So you can keep it with that 1, 2, 3, 4. And you can look to see what your patterns are. Or you can choose other numbers that are easier for you to work with. When we get to our fraction on this last one, let me show you what makes it a whole lot easier for when we are choosing our inputs. I'm going to look at that denominator, say, oh, we have fractions with the 4. I'm going to choose multiples of 4, so I'm going to have whole numbers to work with. So if I do 4, 8, 12, and 16. So what this is saying is 1/4 times 4. What is 1/4 times 4? Clara?
1.
1. And then it's easy to do 1 plus 7 is 8. So if I do 1/4 times 8, what's 1/4 times 8? Elliot? Yeah. 1/4 times 8 gives me 8/4, which is 2. What's 2 plus 7? Elliot? 9. So it makes it an easier number to work with. So when he says choose a smart input, when you're working with fractions, it makes it easier than saying, well, if I had done a 2, 1/4 times 2 is a half point, plus working with those fractions isn't always the easiest when it gets more complicated problems. So I like to choose those multiples of that denominator, so I have whole numbers to work with, so when I'm adding and subtracting, it makes it easier. What is 1/4 times the 12? Clara?
13.
Yeah, because 1 times 12 is 12, 4 times 1 is 4, 12 divided by 4 is 3, and then I have to do that last part, plus 7. So what would my output be, Clara? 10. If I put a 16 in for my input, what would my output be? AJ? 11. Because 16 over 4 gets me 4. 4 plus 7 is 11. Okay. So now, let's look at how we're going to use this information. After a week of timing yourself during your morning run, you discover that you can run 4 miles per hour. Let H represent the number of hours you run, and D represent the distance you run. So that's your input and your output. So instead of using X and Y, they're giving us different variables to use instead of that X and Y. So let's see how we would write this. What would our input be? Henry?
It can be really anything, but I'll say.
But in this, would our input be the H, or would it be the D?
H.
H, because the number of hours you run, you can determine that. I'm gonna run for 2 hours. I'm gonna run for 10 hours, right? You get to decide how long you're running for. So the input is our hours. Our output then would be what? If our input is the hours, what's the output going to be? Laurel? The distance. That is the D. Now we need to write an equation that relates that input to the output. So we're gonna have, oops. You know how we had the Y equals something, so that output, the output's always that, gonna be what it equals, D equals, so that's the output. What math are we doing with those hours? If we can run 4 miles per hour, how do I figure out my distance? Elliot? If I run 4 miles in every hour, and I'm gonna run, let's say 3 miles, or sorry, for 3 hours, how do I know how far that is? I'm not dividing. It's not gonna be dividing because it's not gonna get smaller. What do you think I'm gonna do, Joe? Multiply. So if I can go 4 miles every hour to find out how far I run, that's gonna be multiplying the 4 times how many hours you are running. Okay, we're gonna do more of these, so if this one's a little confusing, it's okay, we're building on it. So we're gonna create a function table that will show how far you run in 3 hours, 8 hours, 12 hours, and 20 hours. Now, here's a really helpful hint for this objective, so I need us all hearing this. I need you to put that away so you're listening. When you are trying to figure out that input, look down to what you're putting into the function table. It's telling us right here we're putting in hours. So that's my big clue that that's my input. It's telling me different hours, so that's the X, or in this case, the H. So I have 3, I have 8, I have 12, and I have 20. That's the input. They're giving us the input. We need to find out the output, the distance. So I have my rule, D equals 4 times H. If I run for 3 hours, what would that be? Clara?
12.
3 times 4 is 12. If I run for 8 hours, how far am I running? Finley?
32.
If I run for 12 hours, how far am I running, Laurel?
48.
And if I run for 20 hours, how far am I running, Bo?
80.
Now, we have to put that information, and we have to use our brain a little bit more. Okay, we have to see what the question is asking us. How long will you need to run to go 62 miles? And then we have a second question. If you burn 250 calories per hour of running, how many calories then are you burning if you run 62 miles? How do you think I'm gonna set this up? I'm gonna use the same rule, but this time I know I'm going 62 miles. I want to find out how long. So how do I do that math, Clara?
62 divided by 4,
Why?
because 4 is,
Where am I gonna put this 62 in this equation?
that's the distance.
That's our distance, so I'm gonna put it in for the D, and that equals 4H. Now I have to do that one-step operation to solve for the H. So I have to do that opposite operation. So if I am multiplying by 4, I know I need to divide both sides by 4. Okay, because I'm doing that opposite operation, so I get my hours by itself. What is 62 divided by 4? Laurel.
15.5.
So to go 62 miles, it's going to take me 15 and a half hours. So that's our first question. Now we have our second question. If you burn 250 calories per hour of running, how many calories will you burn? What do I have to do to solve that question? Finley?
So put that 250 times 15.5.
250 times 15.5, what do I get? So we should all have our calculators out. We should all have our calculators out. 250 calories times the 15.5 hours. How many calories do we burn? Fulton?
3,875.
And we want to label it to make sure we are truly answering our question. Okay? So this was asking 2 questions. I have 2 answers. Does that make sense? All right, let's work some more out together. You pick up a summer job. Mr. Schultz started working when he was only 14. So you start working young, build up that bank account, and your first job pays a base salary of $500 and an additional $9 per hour worked. Let H represent the number of hours you work and M represent the money you earn. So the first thing we want to do is decide which of those variables is our input, the number that we are putting into the function table, and which one is the output, what we're getting out of it. So remember my trick I gave you on how to determine what's the input and what's the output. Which one of these, the H for hours or the M for money, which one is our input? Madeline,
Hours?
how did you know that hours was the input?
Because it can change.
Because if we look down here, we can see we're changing the hours. It's telling us in your function table, this is what you're putting in for the hours. So if our hours is what we're putting in, what are we getting out? Madeline?
Money.
The money. Okay, now we need to figure out our rule. It says write an equation that relates the input to the output. So let's look back. You have a base salary of $500 And you get an additional $9 per hour worked. What do you think that rule is going to look like? Henry?
M equals H times 9 plus 500.
So, we could say H times 9. I'm flipping it around to look more mathy, more proper. So instead of saying H times 9, I'm saying 9H. It means the same thing. I will give credit for either way you write it, but when I write it, I'm going to write it proper math. Okay? And then you said plus 500. Why plus 500?
Because that's your base salary, so no matter what, you're earning that.
That's your base salary. No matter what, you have $500. And you're adding that on to that 9 times the hours worked. Henry?
It's kind of a dumb question, but couldn't you just not do any work and still get 500 bucks?
Yes,
Cool.
because that's your base salary. So if you didn't work, you would be still guaranteed that $500.
That's gotta get a bunch of
Unless your
jobs
boss
out there.
fires you for not working. But not a dumb question.
Well, what if you just work for like less than an hour a day and you still be working?
Again, your boss might not appreciate that. So your boss might say, yeah, that's a no-go, because you were required to work so many hours. So now we need to create a function table. So what am I gonna put on the left? Which letter? Madeline? And what do I put on the right for the output, Madeline? So I know I'm putting my hours in. So it says an hour. What number should I put there? When it says an hour, Clara?
1.
1. Then I have 8 hours. And then I have a week, which is 5 days. So am I gonna put a 5 in there?
Mm-mm.
Well, Ellie, you shook your head no. Why not?
Because that's a day, not hours.
That's a day and not hours. I need to have the same measurement each time. So what do I need to put in there? If it's 8, or if it's a week, which is 5 days, how many hours would that be, Finley?
40?
How did you figure that out, Finley?
Because there's only 8 hours a day of the work.
You're working 8 hours a day for 5 days, which is 40 hours. Then it says a month, which is 4 weeks. What number am I gonna put in for that? Henry?
160,
How'd you figure that out, Henry?
because 1 week is 40, and then 40 times 4 is 160.
1 week is 40 hours, and then we have times 4 for that month. So 160. Now we need to put these inputs into our rule, into the equation, and do the math. 1 times 9 is 9, plus 500 is $509. What if I put the 8 in? What would I get? Elliot?
500.
Yeah. 8 times 9 is 72. 72 plus 500 is 572. Now I need to put the 40 in. I'm putting 40 in for the H. How much money am I gonna make if I work a full week? Victoria?
860.
Yeah, 860, because we do 40 times 9, 360, plus 500. So we get 860. Now, I work a whole month, 160 hours. How much money should I make in a month? Gavin?
1,940.
$1,940. About how many hours do you need to work to earn enough to be able to deposit $750 into your savings account? So now I know my money, but I want to know my hours. So remember, we fill in the variable that we know. So we know 750 is our money. We have that 9 times the hour plus 500. So I fill in what I know for that variable. Now I have to do what to figure out the hours, Clara?
Subtract 500 from 750.
I have to do the opposite operations. I'm gonna subtract the 500 from both sides, and I get 250 equals 9H. Now what do I do, Clara?
Oh, you're gonna divide 250 by 9.
I'm gonna divide both sides by the 9. So the 9's cancel out. What's 250 divided by 9? Victoria,
27.78.
say that again.
27.78.
17?
78.
78. So it says about how many hours. So that means I'm gonna round. I want to round to a whole hour. What am I gonna round that to, Holland?
28 hours.
So I'm gonna work about 28 hours. Now, I have a second question, and oh, for my friends who like to not read directions fully and completely, this is an objective we truly need to read and make sure we're answering all the questions being asked. How do we figure out about how many work days that is? If one workday is 8 hours, about how many work days would that be? Henry?
I believe it's about 54 work days.
So you could say about 4 work days. And actually on here, he actually says or 3.5 days. So he did accept the half. So we have the bottom one. Let's look at that third page, because some of us noticed there's a third page on this one. We have another one here, and another, so we've got 3. So let's look at this bottom one. So on that second page, you have, and actually, you know what I'm gonna do? Let me see. Do you guys have this one?
Yeah.
The building a floor?
Yeah.
Okay, this one is gonna be extra for you to challenge yourself on. Okay, I am going to check us off on the bottom of that second page and the top of the third page. I want to see who's going to challenge themselves to try to get all of that bottom one. If you don't get it all the way done, I'm not gonna mark it as missing, but I want to see you attempt it, okay? So you need to attempt it, and we're gonna see, maybe there'll be a prize for people who are able to show me the correct answer. Okay? So remember our steps. Let's look at this bottom one. Figure out your input. What's the easiest way to figure out the input? Joe? What are we putting in? What kind of numbers are we putting in? That's your input. Then figure out what your output is. Then write that equation. Whatever your output is what that y equals. So the output equals your rule. See if you can figure it out, what that rule is. Make your function table and then answer your question. I'm going to give us some work time in class. We don't have a lot of work time in class. That's why I took that last one on the last page is an extra one. Okay? Gives us some extra work with it. Go ahead. Does anybody have any questions? So what are the giggles for? Is it you don't know what to do at all?
No.
Okay, so start with A. You should have a clue. because I gave you a big hint on what to put with that. If you're able to get started, you can get started. Lucas, well, what was our clue? How did you figure that out? So, oh, so if we look up here, it says let M represent the number of months and T represents the amount of time. So, is this time or is this months? So when I look at my question, how much time if you put in 2 months? So what am I putting in? Am I putting in time or am I putting in months? Yeah, because it has the months listed right here, right? That's the number I'm putting in. It said months, so that's my input. So that's how I know it's months. Then your output is your other variable. So that one's going to be the time. We know to start our rule, we want that output equals, our time equals, then we have to look back up, what's the rule? Your cell phone bill reported that you spent 80 hours on the phone last month. You agreed to decrease that by half hour each month. So if I'm decreasing it by half an hour, what am I doing? What am I starting at? Always. Always. What number am I always going to be starting at? Yeah, I'm starting at 80, right? And I want to decrease it monthly. So I'm starting at 80, and if I decrease, what operation is that? Madeline? What am I gonna subtract away from that 80 every time, Clara?
Half of the
Half of what?
half of what you got last one.
Half of that month. Does that make sense, honey?
I thought it was a half hour, so it'd be like 30 minutes.
Yeah, I felt that.
So, you decrease that time by half. You're not decreasing it by half an hour every month. You decrease it, oh wait. You decrease that time by a half hour each month. So if it's a half hour for 1 month, it's just a half hour.
Yeah.
But if you have 3 months,
Yeah.
you have to have that half.
Okay.
So
Yes.
that one would be, the next one would be that number plus the minus impact, or just that number minus?
What?
For the next question.
For the function table?
Yeah.
So you're gonna put months and time. And our months, we have 2 months, we have 6 months, a year. So how many months is that? And then you have 3 years, which is 36 months.
Oh, now I see. I just did a different way on how I wrote that.
Okay? So fill in your times, answer your E. You're gonna try your hardest to do this one on your own at the top of the next page. We will go through it as a class, but I want you to try so we can answer questions that you have. But sometimes we have to try it on our own to help us know what our questions are. I don't want us to stare at it and say, I have no idea what to do, because you should be able to do A and B, right? You should be able to figure out that input. As I said, look at what inputs they're giving you. If they're giving you months, you know that that's your input. So then you should know what your output is, the other variable. So we should have that starting point. Then try to determine what rule are we doing. Let me see how you wrote it. I'm just curious.
I did like 80 hours minus 30.
Oh, you
Which I guess
converted
kinda
it,
works.
you converted it from a half hour to 30 minutes. Yeah, it's the same, it's the exact same thing. So, you've got your rule. Now you know 20 hours, which is that going to be your months or your time? Okay, so 20 hours on your phone each month is reasonable. How many months will it take you to reach your goal? Your goal is 80 hours. So how many months? So we need to know months. So if we know we want to reach 80 for our months, right? Am I on the right page? I'm not on the right page. Let me show. Okay, I'm over here. Okay, so we have this, right? We need to determine if our time is 20 hours. We're going to put a 20 in for that. And we're going to determine what the months is going to be, how many months it's going to take for us to equal 20. So you're going to do those opposite operations to figure out the months.
Oh, that makes sense.
Okay. Now, a lot of days in math, we don't have homework. Today is a day that we do have homework. Oh my goodness, so many days we don't have homework. Yes, every once in a while we get homework. Today is a homework day. So I do expect you to have that top of the next page done. I expect that done. And I don't want you just slapping down numbers and saying, oh yeah, I did it. It's not going to be missing. Are you going to learn if you just slap down numbers? No. Are you going to learn if you copy a friend? No. Is this objective going to be on our test? Yes. So we truly need to struggle with it. Okay? Not all objectives are super easy peasy. So sometimes it's a little bit of a struggle. If you are in Mrs. White's homeroom, you are headed over to science. My homeroom is social studies. If you are Mrs. White's homeroom and you want your social studies book to study tonight for that test tomorrow, grab your book. It is a big test. It will be on try to. It is a try to grade. They're very durable.
I'm not paying $5. I'm paying social studies.
Not for our review today, but
Okay.
bring it home to study.
Are we doing like the computer?
to stop the recording. So if you are still listening at home, I hope you are well, and I hope to see you soon. Have a wonderful day.